So this is the 7C classwork, and we're looking at finding the number of real and imaginary, which imaginary, I'm going to say imaginary, I really mean complex solutions. So number one, you're going to put this right into Desmos, and in Desmos, we're going to look for the x-intercepts. There's two of them. Both x-intercepts go through the x-axis in a very straight line. If you kind of zoom it in, it's a very straight line. That's a linear solution, one solution. So there you have two x-intercepts, and looking back at the classwork, there are 4 total solutions. The degree is 4, so there are 4 total solutions. If there are 4 total solutions and 2 x-intercepts, 2 solutions, so those are two real solutions because we can see them on the in the x-axis. And there are 4 total. That means there has to be 2 complex or imaginary solutions. All right, for number 2, we're looking at it's in standard form, the polynomial, meaning we have the terms, there's no like terms, we have addition and subtractions in between, there's no simplifying to do on the polynomial. Look at the biggest exponent, that is the degree 4, so there are 4 total solutions. And 4 total solutions, let's look at the Desmos. Desmos, we have, it only hits the x-axis once, but this is a special case. It hits and it forms a quadratic. You could also think of it as the local min or max hits the x-axis, and that would be form a 2. But I look at it as the graph comes off the x-axis or bounces off the x-axis, turns on the x-axis, and it forms a quadratic shape. When it happens like that, that's 2 solutions, so there's 2 real solutions. And there are 4 total, so 2 real, and then there has to be 2 imaginary or complex. Remember, imaginary always come in pairs. So if there are any, it'd be 2, 4, 6, 8, 10. And it can never be odd when it comes to imaginary or complex solutions. Number 3, I'm going to put it right into Desmos again. And I hit the little house and see where it is. Looks like it's crossing twice again. And then both of them are straight lines. They're going through the x-axis, so those are real solutions. So this is weird, but there's 4 total again. Seems like we're doing the same thing. So it's 2 real, and then the other 2 have to be imaginary. Number 4. Maybe we'll do something different here. Put that in Desmos. Aha, we got something different. We have a double solution here at 0 that forms a quadratic quadratic shaped function right around, or the vertex of the quadratic, if we zoom it in, is right on the x-axis. And then we have another solution here at 3. So 2 at 0, 0, and 1 more at 3. So that's 2, 3. So there's 3 total, and there are 3 real solutions. So 3 total solutions, and all 3 are real. And it'd be 0 imaginary. You don't have to have 0 imaginary, you can just say there's 3 real. Which represents a number of real and complex. All right, so let's look at, you gotta put that whole function into the graph. Did it. And what's happening here? Looks like 3 x-intercepts, and all 3 go through the x-axis in a pretty straight line. Those would be 3 real solutions. How many are there total? There are 5 total. And there are 3 real. So if we subtract that off, you get 2 imaginary or complex. So that'd be 3 real, 2 complex. Bam. All right, number 6. Let's get into this now. Given the graph, what is the minimum degree of the polynomial? So you're really looking at the number of turns, slopes. So there's 1, 2, 3, 4, 5. So there's 5 different slopes. So the minimum, there could be more. This could be, but this would be a degree 5. Meaning your function would look something like this: x to the 5th plus ... The biggest exponent would be 5. That's the minimum. It could be bigger than that. That is the smallest. It could be 7, 9, but at least degree 5. So looking at the next one, we have how many different slopes? You have 1 slope, turns, 2 slopes, 3 slopes. It really doesn't matter if you're doing left to right, right to left. You're just counting the number of different slopes. I always just go left to right just so then I remember like increasing, decreasing. So 3 slopes. This means it's going to be a degree 3. It could be a degree 5, could be degree 7, but that's the minimum. Degree 5 and all odds kind of follow the same pattern of how they look. All right, so graph a function is degree 4, so there's 4 slopes, and exactly 2 imaginary solutions. So if there's 4 total solutions, and there's going to be 2 imaginary, then there's got to be 2 real. So if there's 2 real, that means that we're going to have 2 x-intercepts. So I'm going to put the x-intercepts anywhere, it doesn't matter. And we need to have 4 different slopes. So how are we going to do that? So we can go down through the x-intercept. That's ugly. Down through the x-intercept, down, up. So there's 1 slope, 2, 3, 4 slopes, and 2 x-intercepts. So that hits all of our stipulations, so that means there's 2 imaginary. Degree 5, so there are 5 slopes with exactly 2 imaginary. So 2 imaginary, that means there's got to be 3 real. All right, so 3 real, you can pick them anywhere you want. It really does not matter. Space them out a little bit, it makes the graph look a little nicer. And 2 imaginary, so this is going to be degree 5, so you can look back. Degree 5 typically starts bottom left or top left, and it ends in the opposite direction. So the end behaviors are opposites of each other. If it's an even degree, the end behaviors end up in the same spot. They're usually W's or M's. So degree 5, we're going to you start one area, so go down. Man, I can't hit that x-intercept today. Back up, down, and out. So let's see here. Do we have enough slopes? We have 1, 2, 3, 4, 5. Good. And there's 3 x-intercepts. Perfect. That's it. So if you have any questions, please come to class and ask.